Welcome, this is Coach Dorf. We're in section 3.5 and we're looking at a homework-like example. In this one, we're supposed to find dy dx, or the derivative, for this expression where the x's and y's are mixed together. We have to use implicit differentiation to do this. All right, so what we would do is we're going to take dy dx of both the left side and the right side of this equation. So I have d dx of the quantity x cubed minus x times y squared plus y cubed equals d dx of the right side, which is 1. All right, so then to do that, I'm going to do d dx of each term on the left side. So d dx of x cubed minus d dx of x y squared plus d dx of x cubed, y cubed, equals, and now when I take d dx of 1, that's a constant, and the derivative of a constant is 0. All right, so now I have on the left side d dx of x cubed. So that's going to be the derivative of x cubed is 3x squared. And then I would have a dx, which I can just leave off. So I'm just going to write 3x squared. On the next term, I have d dx of x y squared. Now this, I'm going to have to use the product rule here because I have an x times a y squared. So I'm going to write this as the first, which is a y, times the derivative, d dx of y squared. So the first times the derivative of the second, plus the second times the derivative of the first. Put that in a big parentheses or brackets there because I have a negative in front. And then for the last term, I have d dx of y cubed. So that's going to be, derivative of y cubed would be 3y squared. But now since my variable is y, I'm going to have a dy dx. And then again, that all equals 0 on the right side. All right, continuing, I have 3x squared minus. So now I've got x times d dx of y squared. So that's going to be 2y. And because I'm doing the derivative, my variable is y there, I'm going to get a dy dx for that term, plus y squared. And then I take the derivative, d dx of x, derivative of x is 1. And because the variable is x and I'm doing the d dx, I don't need to write any dx term there. Plus 3y squared, dy dx, and that equals 0. All right, now I'm going to make sure that I distribute this negative to both terms here. So I get 3x squared minus 2xy dy dx minus y squared plus 3y squared dy dx equals 0. Now I want to group everything that has a dy dx together and everything that doesn't have a dy dx together. So I have a 3x squared minus a y squared. Those are grouped together. And then I have plus a negative 2xy plus 3y squared dy dx grouped together. All right, the first parentheses I want to bring to the other side. So when I do that, I've got negative 2xy plus 3y squared dy dx. And bringing the other part to the other side, I'm gonna write that as a y squared minus 3xy. It's kind of customary in math if you've got two terms to try to make the first one not have the negative sign out front. So that's why I put the y squared first. You could put the negative 3x squared plus y squared. It's fine to do it that way. And then the last thing is I'm going to divide everything by this parentheses in front of the dy dx. So that's negative 2xy plus 3y squared, dividing that on both sides. And when I do that, I finally end up with dy dx equals y squared minus 3x squared over, and then I'm going to again write this as a 3y squared minus 2xy so that I don't have a negative out front in the first. But you could do that perfectly fine to not switch it around. Anyway, this is what I get for my answer. Hope that helps.